Hello everybody, welcome to another video lesson. We are moving on to geometric sequences today. We're going to find the nth terms and the geometric means of these geometric sequences. So let's hop right into what a geometric sequence is. Now for our arithmetic sequences, we had a common difference that we denoted with D, but now we have a common ratio between successive terms that we're going to call R, lowercase r. So here's the example for our arithmetic sequence. Now for a geometric sequence, however, we are going to be having a common ratio now in between our consecutive numbers. So here we are multiplying by 2 to get to our next term. So now finding our nth term, we can find a formula for that. So our first term, if we said, is a sub 1. Now our second term, we would multiply a sub 1 by whatever ratio we had. And then our third term, we're going to multiply our second term again by that common ratio. So that's going to look like a sub 1 times r. Now for our fourth term, we would again multiply that by our common ratio. So I would have a sub 1 times r again times r. Now you'll start to see a pattern here, right? If I were to put this in exponential form, we'd have a sub 1 times r, a sub 1 times r squared, a sub 1 times r to the third, and you can see that the power here that we have for each term is 1 less than the nth term, the number of terms that we have. So our formula here for a sub n is going to be a sub 1 times r raised to the n minus 1. Now the only thing being raised to this n minus 1 power is r, okay? That's it. It's not a sub 1 and r being raised to the n minus 1. It's just r, okay? Just r. So if you need to put some parentheses around here to help you recognize that, okay, r is the only thing being raised to the power here. So that's it for our concepts, guys. Let's get right into our examples. Geometric sequences. Determine the common ratio and find the next 3 terms. So if I have 4, 11, and 30.25, let's see what we would have here. We would have to find our r first, right? We need to find this common ratio. So we'll do that by dividing our second term by our first term. So instead of saying 11 minus 4 like we did for our arithmetic sequences, we're going to say 11 divided by 4. And that's going to give us 2.75. And we can do that again. Instead of 30.25 minus 11, we'll say divided by 11. And that again is going to give us 2.75. So our r value, our common ratio, is 2.75. So now to find the next 3 terms, I would just take my last term that I have here, and I'm going to multiply that by my common ratio. So I'll have 30.25 times 2.75, and I get 83 and some decimals. Now I'm going to take that 83 and some change, and I'm going to multiply that again by our common ratio. And then I'm going to take that term, and I'm going to multiply that by our common ratio. And these 3 terms here are what we have for our next 3 terms of this sequence. Okay, now it doesn't always have to be a number value, all right? We can have expressions for our terms. So here again, go ahead and pause the video and see if you can figure out the common ratio as well as finding the next 3 terms. All right, hopefully you found a common ratio of negative 1 over 4. And then you're going to have our next 3 terms are going to be negative r plus 2, r over 4 minus 1/2, and negative r over 16 plus 1 over 8. Okay, so those would be our next 3 terms of this geometric sequence. All right, now looking at explicit versus recursive. So we're going to write an explicit formula and a recursive formula finding the nth term in the geometric sequence that we have here. So our a sub 1 we can see is 2. We need to find our r value, our common ratio. So again, I'm going to say 25 divided by 2, that's going to be 12.5. And then 312.5 divided by 25 again is going to give me 12.5, so that's good. We have a common ratio of 12.5. Now we just need to use our formula here for our explicit formula. And I'll say a sub n is equal to, what is a sub 1? Well, that's 2. What's my r value? 12.5. So I just plug those in and I'm done. That's it. That is the explicit formula for this sequence. Now let's find the recursive. So if I were to write this out one term by one term at a time, a sub 1, well, that's just a sub 1, right? And to get to a sub 2, I multiply that by r. And to get to a sub 3, I multiply a sub 2 by r. And to get to a sub 4, I multiply a sub 3 by my common ratio r. And so on and so on. So you could hopefully see that if our if our initial term is 2, so a sub 1 equals 2, remember when we're doing a recursive formula, you always need to give this initial term here. So that's going to be a sub n, this is my recursive formula, a sub n is equal to 12.5, that's my common ratio, times a sub n minus 1. Okay, because when I look to see what a sub 4 is, I need to know what a sub 3 is, and I'm multiplying that common ratio by the previous term, which was a sub 3. Okay, so this would be our explicit, this would be our recursive formulas for this sequence. All right, last example here, find the specific term, or specified term of the given geometric sequences. Okay, so we're looking for a sub 9, so we're looking for the 9th term for this sequence of 4, 14, 49, and so on. So my a sub 1 is 4. My n is going to be 9. N is 9 right here. All right, so I need to find out what my common ratio is. So I would say 14 divided by 12 and 49 divided by 14. That's going to give me 3.5. So r, my common ratio, is equal to 3.5. So now we're going to go and take a look at our formula here of a sub n equals a sub 1, r raised to the n minus 1. And a sub 9, I can just plug these values in. I know what a sub 1 is, and I know what r is. And I know if n is 9, then n minus 1 will be 8, and I can calculate this value out right here. All right, so you guys pause the video now and see if you can't find a sub 12, given that a sub 3 is equal to 32, and r is equal to negative 4. Pause the video, try to find that out. Alrighty, hopefully you got negative 8,388,608, and here was my process of finding that out. Okay, I lied. Sorry, guys. We have one more example. That is geometric means. Again, just terms in between our non-consecutive terms. Okay, so if I'm looking for 3 means in between 10 and 0.016, so I would have 5 terms here, right? 1, 2, 3, 4, and 5, and these 3 in the middle are 3 means. So first thing we need to do is find our r value, find our common ratio. So we're going to use our formula for that. I know that a sub 5 is going to be a sub 1 r to the 4th power. So that's going to be 0.016, 10 times r to the 4th. Divide each side by 10 and take the 4th root of each side, and I get that r is equal to 0.2. So now I'm just going to take 10 and multiply that by my common ratio of 0.2, and I get 2. Okay, so now from here, I would take 2 and multiply that by our common ratio. I get 0.4. Take 0.4, multiply that by our common ratio, and I get 0.08. So these here would be my 3 means. Okay, now that was our last example. Good luck with your practice.